Good.
Yes, sir.
Yes, yes. Good afternoon, one and all present here. It's my honor to welcome our esteemed guest speaker for today's concluding session, Mr. Rahul Rajput. Welcome, sir, for this third session of today. I feel proud and privileged to introduce our guest speaker, Mr. Rahul Rajput. Sir has completed his BE from Rustomjee Institute of Technology, Border Security Force Academy, Tekanpur, Gwalior. He has completed his MBA, PGDM from Great Lakes Institute of Management, Chennai. He has worked as a head of department, braking systems at Team Buccaneer, Supra SAE. Team Buccaneer is a group of enthusiastic engineers from automobile, mechanical, and electrical domain. Sir has worked as sales and service engineer at Launch India Car Scanner. Presently, he is working as an entrepreneur and a founder of RSTE. Finally, I feel delighted to say that today we have with us a very young and enthusiastic personality to speak on design, calculation, and simulation of chassis on SolidWorks. I request sir to please start the session.
Thank you for this wonderful introduction. I feel very honored to be with you, all the experienced persons and the exposures from the different industries. So I'll try to deliver some kind of insight regarding the design and simulation session. So I hope it will make sense to all of you. So,
Surely, sir.
Can I share my screen?
Yeah, please.
Yeah.
Yeah, it is visible, sir. Just put it to slide mode. Yeah, now it's fine.
Okay, so in today's session, we are going to deliver about what are the parameters we need to consider while designing a vehicle or simulation. So we'll cover this session in two segments. In very first session, I'll discuss about what kind of a parameters or the factors we'll consider. In the second part, my colleague, Mr. Pankaj Kumar, will say something about how we can design different objects on the SolidWorks and what kind of analysis we need to implement. Okay, so without further delay, let's come to the topic. So, can anyone tell me what is this picture all about? Anyone, guys? What are you understanding with this picture?
What they used initially to travel.
Jeeps or
Yeah. Any other point? So what is this vehicle? Anyone able to recognize this vehicle? What is this vehicle? This is one of the most selling vehicle of the automobile industry or automobile history. Okay, so let me say something about it. It's Ford T model. Okay, one of the highest selling vehicle in the automobile industry. We all know the Carl Benz is the father of automobile. In the late 80s, when Carl Benz successfully invented IC engine, many of the industry or companies pop up in the market and they started to design four-wheeler. But at that time, four-wheeler was a very customizable. And it's only for the niche market. Only affordable or affluent persons can afford such kind of a vehicle. But Henry Ford had a vision. He thought that, can I make some kind of a vehicle so that it would be affordable for every segment, like a middle class man can afford a vehicle, like a high class man afford a vehicle. So, and it should be a safe, it should be travel with a certain speed. Okay, it should be a good driver compatibility. It should be a comfort for the driver and for who are the passengers. So he had such kind of a vision. So he invented the first assembly line. In this picture, you are able to see a lots of vehicles in the queue. and working, and they are like enabled in the assembly line. So they started to work on the assembly line and it hugely success. Can you imagine that in the 1916, the Ford, when Ford was like selling this vehicle, that cost was around $365. That 4T model was only the cost of the $365. And every industry or every kind of a company was providing a vehicle with various kind of customization, what customer is asking. But Ford designed a standard parameters. Okay, these is my parameters, and I'll only manufacture the vehicle according to my parameters. In that time, in 1960, Ford had a code. The customer could have any kind of a color. Customer could have any kind of a color in the vehicle as long as it's black. So he managed a very standard format. Okay, our industry, our Ford company will make all Ford T model only with the black color, only with this circumstances, 100 inches wheelbase. That's enough. Okay, and how this model start to scale up. And by the end of the 1926, Ford able to crack 16 million sales in the market of this vehicle. So we can understand that in any segment or any industry, there was a one thing that is a necessary, that's need of the market. Sometimes need is a very open, like your customer will come to you and start to asking like what kind of a product or services he is looking for. But sometimes need is latent. Company need to understand that like what is the need of the customers, and after that design a product or services according to that, so that market can able to grasp your product. So for any successful business, there was a one could always mention it: necessity is the mother of invention. Okay, so let's come to the topic. What are the needs we need to consider while designing any vehicle, and what are the objectives we need to consider? So when we start to design our vehicle, the first thing we design that is our frame or basic structure. But basic structure also have a lots of parameters we need to consider. The first parameters are the safety. Safety is the one of the very most important criteria. A family who is purchasing a car will not pay you or invest you some kind of a vehicle which is not safe for his family or for his group. Am I right? If you have two options, one is you are able to get a vehicle in the rupees of 10 lakh and it's safe. Okay, and like it's complies all the parameters, and the second vehicle, it's not complying any of the parameter, but the cost is the 2 lakh. Would you choose that vehicle? Like you have not guarantee like if this vehicle will hit any object, you will alive or not, your family will alive or not. So safety is the one of the most important criteria from the first starting point of automobile. And the next point is a comfortability. If you are driving any kind of a roads, terrain, uh, speeding manner, or taking any turn in cornering basis, so you should feel very comfortable in a car. It should not like that if you are taking a turn, you are going left side or right side, or your family who is sitting in a car, not very comfortable. Every time this vehicle is shaking, every ditch and dip, you are bouncing in the vehicle. So you need to consider a very good suspension quality of a vehicle while designing, so that you are the passengers or the driver feel a very comfort, because it's a daily purpose. Okay. The next point is aesthetics. Especially if I'm talking about India. In India, vehicle is not only for a value proposition. It's more about a status symbol. Okay. So if you have seen that why Nano is badly failed in the market, that was the one of the reason, because of their aesthetics. Because in India, whoever is owning a vehicle, it's kind related with their status. Okay, the person, their neighbors, their families, their friends, who should see this person, okay, this is a kind of affluent person, rich person, he have some kind of a status in the society. So aesthetics play a very crucial role. And aesthetics also play a crucial role in the looking terms, but another also factor need to be considered, that is aerodynamics consideration. While we work on the vehicle dynamics for the aerodynamic section, we also consider the aesthetic in that part. Next is ergonomics. Ergonomics is basically kind of related with the comfortness, but is mostly related with the driver comfort. Okay, what kind of a sitting positions we need to implement in a vehicle so that driver could feel a comfortable, and all the system clusters, gearbox, brake and clutches, all the things should be reachable, and he feel very easiness when operating all these systems. This is all about a driver account. We will see all the topics in details about this. Next is manufacturability. We have a different kind of a tariffs in India. So your vehicles must have sustained a different kind of a road, bumpy roads, speedy, rainy weather. So manufacturing quality of your vehicle must sustain all kind of a various parameters. That is kind of parameter or the factors that will come while you drive your vehicle. The cost is the one of the biggest factor in terms of India. If you are providing all the things, you have a good reliability of a vehicle, you have a good comfort, you have a good aesthetics, you have a good performance, mileage, everything. But the cost of a vehicle is 2 crore. Only a niche market will purchase this vehicle. If you are targeting that market, so that's well enough. But if you are targeting your market for the middle class, if you are targeting for your market for a broad market, so it will be drastic failure in the market. The next thing is reliability. If I am purchasing a vehicle, I'm not going to exchange or sell off this vehicle within some couple of years. I make this mind, I'll purchase this vehicle and I'll use this vehicle as long as possible. Either in 8 years, 10 years, don't know. So it should be reliable for me. I can use this vehicle for a very long time. Feasibility. Feasibility, this is a term bit related with the industry oriented. It's not for the market oriented. A production team have decided all the parameters. Okay, safety tick, comfort tick, aesthetic tick, ergonomics tick, manufacturability, cost, reliability, everything tick. But this design is not a feasible within these circumstances. You have chosen all the circumstances, but this circumstance is not able to implement by the production. So these factors also need to be considered. Okay, so let's discuss about a couple of things while designing a vehicle. First is the application. Okay, tell me something about, let me consider some example. Just suppose that I'm a person who just completed my graduation 4 5 years before, and I'm working in an organization, and now I'm capable to own a car with a finance. Okay, I can finance a car, and my family never had a car. Okay, this is my first car in my family, and I belong from the middle class family. And cost and mileage, these factors is crucially important for me. So, which car, uh, like you will suggest to me? Can anyone answer that? Hello.
Participants, please. I-20, okay.
If anyone want can like type in the chat box. That's okay.
Uh,
I-20. Okay. Yeah, kind of I-20 or Maruti Suzuki. I'll prefer Maruti. Yeah, definitely. Okay. So Maruti Alto, Maruti 800, Maruti Wagoner, Maruti Baleno. Maruti is targeting that segment only. If you are owning a first car and if you belong from the middle class family, definitely the first things that will come in your mind, that's Maruti. Okay. If your salary is good, you can go with the I-20. If your salary is more good, you can go with the upper segment. So that's kind of a behavior you need to predict from what is demand from the customer side. Okay, just let's consider this different example. If I belong from a very rich and affluent family, my father had a business, and I'm also running my business, and it's a success in the market, and I'm making a billions of I'm making $1,000s in the market. Okay, and my family had already 2 to 3 cars. Okay, and I'm a speed enthusiast. Cost is never matter for me. Mileage is never matter for me. The things that matter for me: a, a good looking car, a sporty car, uh, a high performance car. So which car you should suggest to me? Discovery, Jaguar. Okay, yeah, high end car. Yes. Thanks, Amit. Thanks, Ankita. Yeah, definitely. So if I belong from that category, definitely Audi, Jaguar, Mercedes, Ferrari. Okay. So I belong from that category, and industry is also targeting that segment only. If you are belong from particular affluent class, so they will target you. You will not get ads like if you belong from the middle class, if you belong from the uh, 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 working in a professional class, so you'll not get an advertisement of a Jaguar, Lamborghini, Mercedes. Okay, you'll get advertisement like a I-20, Hyundai, Maruti, Tata. Okay, so this is the first according to my application, according to my demand. Companies manufacture their car. So application according to the racing purpose, according to the ATV purpose, according to the commercial purpose, according to the concepts. Okay, so we design different kind of a vehicles. The second important factor is a weight distribution. Uh, most of the peoples have seen that generally in the market we have seen a 3 different kind of a engine positioning car: front engine positioning, mid engine positioning, and the rear engine positioning. Uh, like most of the cars belong from the a normal segment kind of a Maruti, Hyundai, Tata. They place their engine in front side, or Omni kind of a van. They place their engine in the mid type, and most of the racing car or the high end car they place their engine in the back side. Okay, so every vehicle have a different purpose because of the weight distribution. Okay, if just suppose that if I put all my weight in the front side, so what will happen? If I'll take my turn, if I'll take my brake, so it could be panic for vehicle. So I need to distribute weight so that all the forces that is applying from the external or outside that should be distributed around the vehicle, not for a single point. Okay. The third point is arrangement and orientation of the components. The automobile is an amalgamation of thousands of components. The thousand of components is working in a sync. In that a vehicle is running. So all the thousand of components must be in sync and must be supported to each other. If they are applying forces that cross into each other, that against each other, definitely your vehicle will break down. So it's a duty for a designer. It's an essential job for a designer. Whatever compartments the other person is designing, either brakes, suspension, steering, all the departments, all the segments must be supported to each other. Only in that case, your vehicle will run a very long way. Your vehicle will run a comfort way. Your vehicle will support to each. Okay. The next point is about the stability. If I'm driving my car in hilly area, in different terrain area, or in a speedy corner area, if my vehicle is roll over, so what will happen? No one will going to purchase such kind of vehicle. The stability play a very crucial role. Yeah, different kind of vehicles have a different stability. You cannot compare a stability of a Range Rover with the Maruti Suzuki. Range Rover have a different kind of applications for an adventurous enthusiast only. So, but it must be as stable. Either you are purchasing a Maruti Suzuki or Range Rover, no matter. But for the normal road condition, if I'm not taking a extreme cases, it should be a stable. And under low speed or a high speed. Okay, that's also depend on the application. Just suppose that uh, take an example of Lamborghini or Ferrari, they have a very low ground clearance because who will run this car will run only in the high speed tracks or only run in the very flat road. They are not going to take their Lamborghini in the hilly area or a very bad terrain area. Okay, so they know that they are targeting customers only such segment who will run their vehicle in kind of a high speed track or kind of a very clean road. So they provide their very low uh, center of gravity and ground clearance of the vehicle so that stability could also be improved. And in the second side, if you will see uh, Land Rover or a Jeep kind of a car, so they know that this car is designed for all terrain vehicle. The person who will own this car who can go in the mountain area, who can go in the hilly area, very bad terrain area. So ground clearance should be very high. In the same time, we need to maintain a stability with the low speed because they will not run their vehicle 150 kmph on the hilly area. Okay, so in the low speed, how we can manage the best stability of a car? They are focusing on that segment. Next is compatibility. This point is bit related with the events or parameters for which you are designing your vehicle. Just suppose that you are working in a Tata Motors. So Tata Motors have some kind of compliances. You need to follow these rules. Okay, and if you are guiding those students who are participating in any events, kind of a Supra, Baha, or SUVC. Okay, so every event will give you a rule book. There are sets of rules, and you need to design all your vehicle or components according to these circumstances. So you need to design your object or your vehicle according to that circumstances. Next is range versus efficiency. That play a crucial role. Okay, if you design a car and if you're targeting a middle segment, but your car is able to deliver only 6 to 7 kilometer per liter mileage, so it will not make sense. Efficiency matter for that. Okay, if you are targeting for budget class customer, if you're targeting for the middle class customer, your range should be something 15 to 25 mileage, 15 to 25 kmpl mileage. Next is cost versus quality. You need to optimize your quality. If you are targeting middle class segment, you cannot use the carbon fiber. Okay, and if you are targeting a very high class budget, something 2 crore or 10 crore, you cannot use the steel pipes. So everywhere a different quality. If you are carbon fiber is a very high cost, but lightweight, and the quality of a product could sustain a very long process. Okay, but steel tube have a different quality. So you need to optimize that. Okay, what my cost, and according to that, what best quality I can provide this. Factor of safety is the next term. Generally, we prefer for the car, factor of safety is 1.252 range. It could be range up to the like 3 to 5. Okay, if you will see that Japan train, or if you will see that the Indian train, so they have a different factor of safeties. India have a different conditions. We are designing our trains something around 8 to 10 factor of safety. Yeah, it's over designed, but it's a necessity of that area. If you will not design a very high factor of safety, you cannot assume that like which kind of applications the passenger will do with the car. Even in the trains, they designed for fan, they designed for the casing of a fan. It's a much more higher factor of safety as compared to the normal purpose, because they knew that the people of India will do something, they will something definitely do with this fan. Okay, so factor of safety depend different area. The next is the availability of the manufacturing facility for the product. Okay, just in case if you are guiding your students or participating in any event, and they're deciding that sir, let's say we should make a 3D joints. Okay, but uh, your college or your industry does not have the capability to design accurate 3D joints. So it could be fail your design or it could be reduce the efficiency. Although 3D joints could have improved your efficiency compared to the 2D joint, but you have not a manufacturing capability. So in that, you need to optimize that. What are the facilities I have? And according to that, optimize that facilities and utilize that and produce the best design rather than just focusing the next level and we don't have a resources at that time. Okay, so let's next slide. Okay, just look in these two pictures. What I was talking about 3D joint or 2D joint. In this frame, this is 3D joint. My pointer is visible. Can anyone confirm me? Gaurav, have a question about why people not purchasing. We will discuss this topic. We will discuss this. Yeah, this is a very fast topic actually. I'll discuss this point about. Okay, so in these two pictures, okay, what I just want to demonstrate here is the 3D joints. Okay, this is called 3D joints. Okay, just see this. This is my plane, and I want to make my frame from this point, this point, this point, all four points. Okay, and it should be like joint in between this plane. But if I'm putting my joint not in the plane, but some height from the plane. Okay, here, suppose it is connecting this, it is connecting this, it is connecting. It kind of a complex, and it need a very good efficiency. Sometimes you need to bend your pipe. Okay, so if you have a bending CNC machine, so definitely you could make a better efficiency. But if you are doing it manually, it could make some mistakes, and a single mistake can reduce the overall efficiency of your 3D joint. Okay, so in the next example, next picture, here you are seeing that it's a 2D joint. Okay, most of the vehicles, those are participating in Supra or a racing car event. These both are the pictures from the Supra events. Okay, so this is the 2D joints. Most of the teams who manufacture the Supra vehicle, they generally use the 2D joint because it's easy to manufacture, easy to design, and easy to implement. And it also have a good efficiency. But if you are able to implement very like goodly way, the 3D joint, definitely you would have an advantage. But in 2D joints, you can also improve your efficiency. But it not makes sense if you are poorly designing your 3D joints rather than the efficient designing your 2D joint. Okay, so here is some videos. Just look on it. What we are discussing about application of the car according to the market segment. Just look on that. How companies are designing their cars according to the market segment. Okay, and what are the priorities? The priority is a mileage, or priority is aesthetic, or priority is a performance, or priority is adventure, kind of excite speed. Just look on it. Is audio is coming?
Yes, sir.
Okay.
No, not
Video
yet.
was audible.
Ah,
Video was audible, na?
no, sir.
Okay. Just
Now video is coming.
So how was it? You can type in the comment, that's okay. So in this video, they basically focus about the SAR groups, that vehicle that can excite for high class consumer, adventurous and the sporty look. They did not talk about the cost, they did not talk about the mileage, they talk about speed, excitement, adventurous, and sportiness. Okay. Just look on the next video and tell me in the comment box after completing this video what are their like focusing area.
After years of intense work, Lexus is ready to celebrate. Because even at the equivalent of 145 miles per hour, the Lexus LS400 is designed to stir the soul and not much else.
After years of intense work, Lexus is ready to celebrate. Because even at the equivalent of 145 miles per hour, the Lexus LS500 is designed to stir the soul and not much else.
Happy anniversary, Lexus.
Stability, elegance. Great. Guys, I would like to more answer. I would like to hear more answers. So what's your comment? You can type anything. Yeah, means there are various kind of factors with associated with this vehicle. Okay. So here Lexus is more focusing about the comfortability, elegance, stability of the car. Their primary focus about stability. Okay. Just one more video.
I think the first time you arrive here, it's just totally mind-blowing. Oh, that's steep. I'm here to do the Dragon Challenge, to drive the Range Rover Sport plug-in hybrid, the 99 turns, and then drive up the 999 steps, all the way to Heaven's Gate. 天门山 is just shrub.
对，也有很多老人说起天门山一些故事。路的话本来就是很灵动，那99道弯就是像一条白龙盘踞在天门山。
我们这儿这个山石壁就是一都缺，这个公路稍有不慎，那就是致命的。
Electric motors deliver instant torque. It's just going to give you that extra boost.
You ready?
我建议还是慢点儿。
我在这儿工作了13年，也就是像我们一般30、40过弯就已经够快的了，对，尖叫是很正常的。而且它的坡度又大，弯道又多，只要一点点的那个出一点点的瑕疵，都可以不是小事故，很危险，所以刚开始肯定会开业会很紧张。
可是如果我告诉你，他也要把车开上天门山的阶梯呢？999道阶梯。
开天梯，
上天梯就是从开元到特别大，
觉得可能性不大。
那个不可能的，
那不可能的，
不可能吧？还是因为车怎么开得上去那么高的天梯
This challenge is the most extreme one we've done yet. The plug-in hybrid, having that grunt of both engine and electric will be a great benefit. But we're really pushing the limits. There really is a chance of failure. As far as I know, nothing has ever been tried like this before. This is unheard of. It's crazy.
It's very steep. It's 45 degrees. Well, yeah, it's like this, right? Yeah.
这样。
那也没那么陡，这么样子吧，是一个很可能会带来危险结果的事情。
I can't see anybody living if the car started rolling back down the hill.
如果发生这个意外，那就是车毁人亡。
Nice and steady. Yeah, we're clear, mate, don't worry. You be very careful up there, please. We're clear, don't worry. Everything's clear, everyone's out of the way. All clear.
So after watching this ad, if you don't have a cost constraint and if you want to purchase a ATV vehicle, which vehicle will come in your mind in a very first basis? Definitely a Land Rover, because they are testing their vehicle with the extreme limits, whatever you can imagine and whatever you can go once in your lifetime. So That's how they are positioning their vehicle in the market. Okay, so any company who started to design their vehicle, they not suddenly started like just two designers in the company and they just thought some kind of a design and they started to design it. Okay, they make some sketches, but for complete design consideration, first they need to understand what's the market demand, what's the market feedback, market survey. They collect some clues from the market, actually what kind of a product or services actually market is looking for, what is the like hidden needs of the market, and after they collect all the points and they connect all the points and they started to design it. Primarily, designers make some sketches and according to that, optimize that design, what are the rules and the constraints they have. And after, automobile is a comprises of thousands of departments, thousands of parts. So each and individual part designed by the different design teams, and after they collaborate all the designs in a single place and assemble all the components. Like after that, they check the ergonomics compatibility, weight distribution factors, and simulating all kind of critical modifications, all kind of conditions with their different loading capacities. Like they are applying the crash test, they are applying the frontal impact, they are applying for the rear impact, and different kind of factors if they are applying, and how this design is sustained or not. Okay, and according to that, when your design is failing in this particular point, they are modify that design. And after all the consideration, when they check all the steps, when they complete all the steps, they final the draft and documentation part complete. This is not like consecutive steps. First, this complete need to do, then next. These all steps will work simultaneously. Like ergonomics checking and the weight distribution could be parallelly with the primarily sketching design or the individual parts designing. Okay, so these are like all steps will do simultaneously. So let's something discuss about what is the chassis and what is the frame. So before discussing about it, can anyone tell me about like what is the difference between the chassis and the frame in chat box, or you can open your mic, we can discuss about it. Okay, so should I go ahead? Chassis is the base of a car. Okay, this is in a metal. You can call it as a foundation. Yeah, that's great. Okay, I understand, guys. You are taking session from morning and it's your last session. But that's okay. Let's make this more interactive. And you can say that if I'm boring at any time, if I'm boring you at any time, you can say to me. Yes. Oh, that's great. Tejas, Gaurav, Anil. Yeah, that's great. That's great. Yeah. Uh, frame is really a skeleton of your vehicle. Okay, where you can assemble and where like what the particular things that will hold all your segment, all your departments of the vehicle. That's your frame. Okay, generally known as skeleton of your body. And whatever the essential compartments that will hold in your frame that can run your vehicle. Okay, that part is called a chassis. Okay, what is the minimum requirement of a vehicle that can move your vehicle? Okay, so here we can understand that like body and aesthetics that will not come under the chassis. Okay, you have seen a couple of times that truck that without a container only a driver compartment is there, and that open in the back side. Okay, that part is called as a chassis. Commonly used material for a vehicle. So when we design a vehicle, we generally use the three kinds of material. Either we use a steel tubes, either aluminum kind of alloy metals, or carbon fiber materials, or kind of related with the glass fiber also. Okay, so every materials have a specific every material have a different kind of specifications and different kind of a rules in different types. Okay, so when my budget is not so good, my budget is limited, and I need to make a good quality vehicle, weight is not a constraint for me. So in that case, I'll use a steel tube. Okay, if weight is a major constraint, okay, and budget is also need to be considered, I'll go with the aluminum tube. And the budget is not a constraint for me, and I need to make a very efficient, lightweight vehicle that could deliver a high performance, I'll go with the carbon fiber. Okay, so can anyone tell me like most of the vehicles that are available in the market, or uh, most kind of a projects that we participate either in Supra, Baha, we use generally the steel tubes. Why we use steel tubes? Is this for specifically? Okay, so basically for us, major constraint is manufacturability. Yeah, cost effective is one of the major concerns, but if I'll not take the cost consideration, because if you are able to crack some good sponsorship from the market, uh, uh, you can put the lots of cost in your vehicle. But the major constraint is manufacturability. We have a limited resources in college. Okay, you are not running an industry, and even for the industry, we have not each and every kind of machinery. So everyone have a different manufacturability constraint. Okay, as far as like if I'm concerned with a college project, so our major concern with the manufacturability, we have a limited resources for the welding, okay, for the grooving, cutting, or bending, everything. Okay, so we prefer the steel tubes because uh, weight is a factor, but not a major factor. If you are participating in a solar vehicle, definitely weight is a major concern. In that case, like some couple of the teams, you will see that they use glass fibers for their chassis, for their whole body.
I guess some technical disconnectivity is there. We are trying to connect with sir. Please have patience. I guess some internet disconnectivity is there. We are trying to connect with sir, right?
Hello. Sorry for disturbance. Actually, there was
It's
some
fine.
internet issue.
Yes, sir.
Sir, I'm not able to share my screen. Yeah. Thank you. Okay. So we are discussing about the cost of material. Am I audible?
Yes, sir.
Okay. Thank you for confirming. Okay, so these are the couple of factors we need to consider while selecting our material: strength, weight, stiffness, cost, durability, and reliability, and manufacturability. Okay, these are the couple of concerns as a frame. We have already discussed a couple of things. So, what are the mechanical components or the vehicle dynamics that carry a load as a frame? That all the factors need to be considered while designing a frame that will carry a weight of the vehicle in a passenger vehicle or a cargo road. So according to the stability or according to the strength, we need to select our vehicle, our material. And what are the mechanical properties we need to see? Either is yield strength, shear stress, tensile strength, longitudinal tensile forces. All the forces we need to calculate while designing a frame or while selecting a material for a frame. Okay, so let's consider an example. You take a steel tube, its diameter is 25.4 mm and thickness is 3 mm. Okay, and the second time you take a pipe that internal diameter is 31.75 mm and the thickness is 5 mm. Okay, so if we will go with the calculation, so you will see that the bending strength something about the 300 Newton meter and bending stiffness in 2700 Newton meter and weight of the 1 meter is something around the 1.64 kg. Okay, and if we'll go with the calculation with the second type, we will find that bending strength something around double from the first piece, from the first object, and stiffness is also a 1.5 times higher than the first object, and weight has reduced from the first object. So we should choose material after all the calculation. So here you can see that if I choose the second object compared to the first object, I can reduce my weight 26%. Okay, and my bending strength is also improved. Because if you will go with the formula of bending strength and bending stiffness, its internal radius or internal diameter of a hollow pipe play a very crucial role. If you remember the formula, that's pi by 4 r to the power 4 internal minus outer. So your radius to the power 4 that play a very crucial role. Okay, these all are the factors need to be considered before design a frame. Like some couple of points we have already discussed: weight distribution factor and height of CG that control your vehicle stability and handling and the ground clearance, and bending and torsional stiffness of a frame. If you are designing a solar vehicle or an electrical car, definitely you need to work on your panel area because that must be tap maximum solar power so that you can utilize maximum efficiency of your vehicle. Okay, and space of your driver compartment. Your driver should be comfortable, feel comfortable when he or she driving a car. So space of the driver should be ample so that he can operate each and every instrument cluster, gear, and like clutches, panel, everything with a very smooth manner. The dimensional limits yeah, if you are designing for a vehicle, if you're designing a car for an event, definitely you need to consider all the dimension limits from the rule book that is specified. Okay, these things about vehicle distribution, weight distribution, and the vehicle dynamics. We generally studied three types of a motion of a vehicle. First, uh, first is a rolling. These are the failure mode. Okay, when vehicle is running, what kind of a vibration on what kind of a failure could have been happen. Okay, so just suppose that if your vehicle is going straight way and it's rolled such a way or such a way. Okay, left side or the left right side. So it's called a rollover. Okay, your vehicle is rolled over. If your vehicle is going straight away and it's this kind of a motion is happen. Okay, so it's a U-ing motion. Okay, it's because of your suspension and because of your steering. Okay, and if your vehicle is steeply going downward and when you are accelerating, your vehicle is going upward. Okay, so it's called a pitch of your vehicle. Okay, when you sudden panic your brake, okay, it goes deep down, and when you are accelerating your vehicle, your front side is going upside. Okay, so that's called a pitch. So in all the three dimensions, we need to consider while designing, and apart from frame, like other compartment like a suspension, steering, all the things we need to consider all the factors. So these are the couple of factors of the weight distribution of a car with the hilly area. So just look careful this video. It's very well explained about the frame, step by step, like how we design a frame and which kind of a mountings, which kind of a points we need to be considered. It's a very old video, but a very relevant video.
Automobile, the foundation is the frame.
The video is audible?
Yes, sir.
Anyone?
Yes, sir.
Yes, sir.
Few people see the real foundations of their houses, and few owners see the frames of their automobiles. And there are many important engineering developments in the modern automobile frame, which aren't apparent when you look at the car. Let's see what an automobile frame has to do, and what kind of a frame is required to do the job. This line is the road. These are the wheels, and this is the body. Now let's look at it from another viewpoint. Looking down on top of the car. The car is supported at four corners by the wheels. We must have a strong, rigid foundation to support the body over its entire length. So let's take off the body and build a foundation, starting with these two pieces of steel, which we will call side members. Now we need something to keep the side members apart and something to hold them together. So we put in two more steel pieces, which we call cross members. But how are we going to turn those front wheels? They haven't enough room. Well, let's give them all the room they want. Let's make the frame narrower in front. That's better. How about the rear end of the frame? We've got one cross member, but that's not enough. It will give us a good, rigid support for the gas tank, but we need something stronger than that. Let's put in another one that makes the rear of the frame strong and rigid. And just to make sure that our foundation won't go together in the middle like this, let's put in another cross member right about here. Now we have a frame that you can't pull apart, that you can't push together. Pretty good job as far as we've gone. Hey there, that won't do. To prevent this sort of thing, let's put in some more steel girders like the letter Y. Now, any force applied here will be transferred to the center of the frame. But we don't want to be compelled to make this center crosspiece too heavy. So, to help spread the strain, let's put in these members, like the letter K. Of course, we have to consider the engine. We're going to support the front of the engine here. So we'll have to have another cross member here to support the rear of the engine. Now we've designed a skeleton frame. But before we ride on it, we'll have to do some figuring. And the first thing we want to know is, what part of the frame is going to get the most severe strain? Or, as engineers would say, where is the point of maximum stress? This is a piece of steel supported at each end. We apply a weight at the center of this piece of steel. We let the steel bend up and down, and it doesn't break because the strain is equalized throughout its length. But suppose we fasten a steel box over half the length of the beam and again apply the weight. Up and down it bends, but this time it breaks because while this end was held rigid by the steel box above it, this point was doing most of the bending. Right here at the edge of the box was the point of greatest strain. As an engineer would say, the stress was localized. So it is with an automobile frame. The point of greatest strain is here at the front edge of the steel box or body of the car. And on the frame, that point is here. The usual way of building this part of the frame would be to use only one piece of steel. But in this frame, we're going to use two steel girders like this and tie them together with a heavy steel plate known as a gusset. This construction gives us rigid strength where we need it. Another point of great stress is here. So here again, we add a heavy steel plate to give us extra strength. When we ride on the frame we have designed, we'll find that there is another point of heavy strain, here in the hump, where we bent the side member up to get over the rear axle. So we'll give it a reinforcement too. Since we are going to have harmony between the front and rear springs, knee action, on the car we are building, let's make the front end of the car as rigid as possible. With knee action, we use this sturdy girder of steel to hold the wheels. It's time to add these brackets, called step hangers, which support the running boards. And now look out for the rivets. Here they come. "219 tough steel rivets to hold our frame together. Cold-driven rivets, too, that won't shrink after they're in place. Now we have a strong, rigid foundation. With this YK frame, your car will stand up under the hardest usage for tens of thousands of miles. Strong, heavy side members for support. Sturdy cross members for rigidity. Big steel center braces for strength. Heavy reinforcements at points of greatest strain. A good husky support for the engine. And a strong crosspiece to hold the knee action wheels. Such a frame gives rigid support to the whole car. Springs, steering gear, and engine have a firm foundation. The body and every part of the car ride on a frame that is solid, strong, and safe. With such a foundation for your car, you can ride on good roads or bad roads or any kind of road. Your car has a foundation to protect all vital parts from damaging shocks and strains. Summers and winters may come and go, but such a house on wheels will never have to fear the creaks and rattles of a home foundation.
So this video is explained a very broad view about the frame designing. More or less, like designing has changed drastically from decades, but the basic concept remains same. What we discussed here, we are still using the same kind of concept while designing a frame. Okay, so here we are discussing about which members called the primary member, which called the secondary member, and which called the smart member. Some couple of events also called the tertiary member, but I remove the tertiary member rather than I call the smart member. Okay, so primary member that is used for support your chassis, where you are where whatever the members where you are uh, placing your other compartments, where you are placing for the other compartments, and when you are just that compartment is holding with the frame. Okay, in that case, in this frame, just see that. If I talk about the primary members could be my outer layer, this one, the supporting members. If I'm just placing my engine in the back side, so my engine will be held by the primary members. Okay, the suspension points, the steering points, all the members who directly connected with the frame that will hold by the primary member. The secondary member is for the transmission, is for the load distribution. Those are the supporting for the primary member. Okay, just look at this frame. If I'm just talking about this portion area, upper portion area. Okay, so outer area is a primary members, but in the in middle, if I'm talking about these bands and these bands, this is called as a secondary member. Okay, this is only supporting this section. Okay, if I'm talking about this particular area, so this is my primary members outer side, and this is my supporting member. This is called the secondary. Okay, in third point, there are the smart members. Some couple of smart members we will include, so that my stiffness or my strength of weight will be drastically improved. In the last video, you have seen that gadget that implement in the frame that for the smart member that will improve the strength of your vehicle. Okay, with the small piece of a metal that could drastically hold the couple of members of your frame. That's called as smart members. Okay, and when we are placing our compartments, either it's an engine compartment, either it's suspension compartment, like where we will get direct vibrations or external forces from while running a vehicle. So all the compartments, all the mountings should be consist of the primary members. Okay, because primary members could distribute all the forces in complete frame. If you will connect on the secondary members, it could break. If you connect with the tertiary or a smart members, it could be break. But if you will connect on the primary member, it will distribute that force will be distributed overall in the frame. Okay, these are some ergonomics points while designing a driver compatibility area, while designing a seat, while designing a driver position or the sitting position, we need to consider some couple of angles, because when you are running your vehicle for a couple of hours, you feel very comfortable. You cannot run a vehicle with pain in your back, with pain in your elbow, okay, with a very uncomfortable position. So we need to design a very comfortable, very ergonomic position so that driver can hold this position for very, very long time and without any fatigue. Okay, so these couple of points we need to consider, like a sitting position, SP1 and SP2 position. SP1 and SP2 position are the positions. SP1 is a sitting position for first and second. SP1 and SP2 position are the position of the driver, where he can see the front area. Okay, if the visibility is related with the vertical area in this, okay, here you. In the bottom figure, you can see that from generally for the car, it's a 1.5 meter SP1 from front end of the car to the length that parallel to the road. Okay, this point should be visible by the driver eyes. Okay, so this distance is called for the SP1. This is for the vertical area, vertical side, if I'm able to see 1.5 meter distance from my eyes and from the front end of the vehicle, so it is called the SP1, sitting position 1. And if I'm able to see 100 degree that side and 100 degree that side, sorry, not 100 degree that side, complete 100 degree angle from my eye position, that is called SP. Okay, horizontal visibility called SP2, vertical visibility called SP. Okay, while designing a vehicle. And steering wheel angle, size of the steering wheel angles and the elbow angles, pedal angles, these couple of angles we need to consider. Here you can see that this is the H point called hip point. This is my elbow angle or shoulder angle. Okay, this is my foot angle. This is my knee angle. So what are the parameters actually generally company considers or generally events consider? Let's discuss. Let's deal with that. Okay, for the general vehicle, we consider the leg angle 120 to 150 degree, hip angle for the 90 degree, and elbow angle 120 to 160. Okay, if you are designing a racing car kind of a event as Supra, so you consider the same kind of a parameters because you have to run a very long and very high speed vehicle. And if you're designing a vehicle like a Baja or other kind of events, so you can compromise such couple of things, but it should be a comfortable. Okay, this is a limit 120 to 150 degree. Whatever you are choosing, it's okay, but it choose according to your application. In SolidWorks also or ANSYS, if you want to analyze all these factors, you can go some commands. There are some dummy you can design and some couple of details or commands you can use that to design all the angles with the different points. Okay, so in frame, we consider the stress. What are the load that putting in a per unit area? Stress is an external property. Okay, when external force is applied for material, so what amount of force that one particle is distributed their neighboring particles. Okay, that is called a stress on a per unit area. There are different kind of a stress we generally study: compression, tension, shear stress, bending, torsion, or fatigue, and we analyze with all these terms while designing a frame. Okay, and another part is also strength, but both formula are same. If you will see the formula, strength is also load per unit, and the stress is also a load per unit. But strength is an internal property. Strength is an internal property of a material, while stress is induced by the external loading. When your object have a greater strength than a stress, so there will be the no failure and no problem. But when stress is greater than a strength, your object will fail. In this particular picture, you can see that if I'll apply the tension in this object, when my stress will be greater than strength, your piece will break down. Okay, so this is one of an interesting topic, not really very related with the frame, but related with the body. Lots of a time, company take a inspiration from nature. Okay, they design their vehicle to take inspiration from the nature because nature have a best mindset for designing. Okay, nature is called a master of design. So we take inspiration, either you are designing a vehicle, either you are designing a train or any kind of object. So nature have every kind of a design availability. So that process is called a biomimicry. Means you take an example of any animal species and you try to copy that behavior, copy that nature is nature like advantage they have given, and we'll try to implement that advantage in our species, in our object or in our vehicles. Okay, so in that picture you can see that a designer is sketching by taking the inspiration of the Shah. Okay, so can anyone say that on which car this designer is similar? Okay, from which car this design is matching? The chat box, anyone say that? Innova. Okay, that's interesting. Tesla. Exxon. Okay. Actually, in this video, they didn't. That person didn't tell that like which design, like which company this design is matching for. But I was, it designed looking like to me was kind of a Lamborghini Aventador, because Lamborghini use such kind of a headlights, sharp headlights, and use such kind of a front, like front frame, front body. So I feel some kind of a Lamborghini design. Yeah, but yeah, Marajo is okay. Marajo is also inspired from the Shah. Yeah. Okay, so it's just an example like how we inspire from the nature and design this vehicle. Okay, so just see a small video how a Japanese bullet train take inspiration from the nature and they improve their design. It's a very interesting.
In 1989, Japan's Shinkansen bullet train had a problem. It was fast, really fast, like pushing 170 miles per hour fast. But every time it exited a tunnel, it was loud. The noise was coming from a variety of sources, but whenever a train sped into a tunnel, it pushed waves of atmospheric pressure through the other end. The air exited tunnels with a sonic boom that could be heard 400 meters away. In dense residential areas, that was a huge problem. So an engineering team was brought in to design a quieter, faster, and more efficient train. And they had one secret weapon. The manager of the technical development department was a bird watcher.
Different components of the redesigned bullet train were based on different birds. Owls inspired the pantograph. That's the rig that connects the train to the electric wires above. Nakatsu modeled the redesign after their feathers, reducing noise by using the same serrations and curvature that allowed them to silently attack prey. The Ellie penguin, whose smooth body allows it to swim and slide effortlessly, inspired the pantograph supporting shaft, redesigned for lower wind distance. And perhaps most notable of all was the kingfisher.
The kingfisher is a bird that dives into water to catch its prey. The unique shape of its beak allows it to do that while barely making a splash. Nakatsu took the design table. The team shot bullets shaped like different train nose models type to measure pressure waves and dropped them into water to measure the splash size. The quietest nose design was the one modeled most closely after the kingfisher's beak. When the redesigned day less electricity and decibel limit in residential areas. It did all that with the wing of an owl, the belly of a penguin, and the nose of a kingfisher. There's a name for design like this. It's called biomimicry.
The people who design our world usually never. So they're novices in how the world works.
That's Janine Benyus. Back in 1997, she wrote the book that coined the term biomimicry. It told energy and inspired publishers in the natural world.
Think like a gecko, compute like a cell, run a business like a redwood forest.
Benyus has since worked as a consultant for various companies, trying to get them to understand how to take design ideas from nature. That might mean studying prairie dog burrows, build better air ventilation systems, shark skin to create bacteria-resistant plastic surfaces for hospitals, or arranging wind turbines in the same drag-reducing pattern that schools of fish swim in. Designers get inspiration from a lot of different places, but Benyus thinks many of them could benefit from looking more at the natural world.
So there's a lot of sort of looking at what other people have done, and what they do is they look at all the others, and they get ideas. They literally do, you know, a lot of designers have lots of magazines that they look through. They tear those out and they put them on inspiration boards. But they're looking at other human technologies.
Her idea was simple. Designers should get in the habit of bringing a biologist to the table and let them help solve problems by mimicking nature. And there are three main ways they can do that.
You know, you can mimic its form or its shape. You might create a paint for a building that when it dries, it's got the same structure as self-cleaning leaves. Lotus leaves are notoriously great. They let rainwater clean the leaf because they have these bumps, and the rainwater balls up on the bumps and then it pearls away the dirt. So that lotus effect is physical, and you can create a physical structure on the outside of any product. Imagine that on the outside of your car. Rainwater would clean your car. So that's mimicking form. But there's also mimicking process, the processes in the natural world. It might even be, you know, how you mimic how ants communicate in order to efficiently find sources of food or new places to live. And those processes, that self-organization, has been mimicked in software. You know, in things like autonomous cars and how they're going to move in flocks through the city by talking to one another. That's mimicking nature's process. And then you jump up to the level of mimicking whole ecosystems, right? There's a thing that's a buzzword right now that's really hot called the circular economy, which is essentially, you know, industry saying, you know, there should be no such thing as a byproduct in our manufacturing facility that goes to landfill. It should be used by something else, right? And at the end of a product's life, that product should be upcycled into something else. It's being called the circular economy. Ecosystems do that really, really, really well. You've got a log on the forest floor, and those materials move up into the body of the fungus that eats it. Those materials move up into a mouse, and that mouse material moves up into a hawk, right? And if you think about that as what we'd like to do with local materials being upcycled constantly in our cities, for instance, those ecosystem lessons are really big for us.
And that's the end goal for biomimetic design, making products, systems, and cities functionally indistinguishable from the natural world. Life has been around on Earth for 3.8 billion years. And what designers are starting to realize is that is a lot of research and development time.
The people who design our world have a lot to learn from the natural world. All they have to do is take a look.
Thank you so much for watching. This is...
So this part will cover by my colleague, Mr. Pankaj Kumar, like what kind of analysis we generally do for the front analysis, rear side analysis. So that's all from my side. Thank you so much. I hope you enjoyed this session. And if you have any query, you can ask me, you can mail me. The floor is yours, Pankaj sir.
Yeah, hello. Am I audible? Hello.
Yes, sir. Yes, sir.
Okay. So first of all, thank you for inviting me here to give you a brief explanation about the design. So let's start. So first of all, what is the design starts with engineering. Okay. So what is engineering? Engineering means we have to make something for the society by using our knowledge, and just like we manufacture vehicles, we design vehicles, we make many different things. It may be civil engineering or chemical engineering, anything else. So in engineering, there is a part that is design. So in the design part, there is many different type of designs. So first of all, we will understand what is the need of the design. So design is not something you should have of which knowledge you should grasp, but design is something you should have a feel. Designing is about feeling whatever you are preparing or manufacturing. Okay, so first of all, let me show you something in around the globe, many people make some planes or something like that. Okay, first of all, let me share my screen. Okay. Yeah. Okay. Is my screen visible?
Yes, sir. Yeah.
Okay. So first of all, let me show you. There's some people around the globe, like in India or Nepal, who is just wait. Wait. Yeah, hello. Okay, so there is some people around the globe, or basically in India or Nepal, who are having a fertile mind, very innovative mind, but lack of knowledge. Due to lack of knowledge of the design, they came to some failures in whatever they were inventing or making. You can see there is a person who is who had decided. That person was having dream of making a helicopter for himself. Okay, so but are you comfortable in Hindi? Because to make feel of the engineering design, I must use Hindi along with English. Hello.
Yes, sir. Yes, sir. Please continue.
Okay. So basically, in इसमें हुए क्या? So here you can see those people made some kind of helicopters. They thought that by using an engine or using some kind of blades or propellers, they can make a helicopter or something like that. But you will see they prepared everything here. Okay, they just copied the shape, whatever kind of pipings and everything structure from the original helicopter available. But the problem you will see here in this design is that they didn't made any calculations or designing, or their designing part is very weak, because they didn't make calculation about how much thrust their system is producing, how much weight they have, what are the boundary conditions that will be applied over this system, and what are the sources of the lift forces needed in this structure. Okay, there's many other designs you will see there. People just use the here that person used the Maruti 800 engine because that person is not having knowledge of how much lift he needs, what will be the weight of the whole complete structure, and how much lift according to that weight and that person will need, and what will be the accelerations and all the parameters. That person is not having anything, and because of that this person didn't optimize this structure. The selection, that person is not also not having the selection of the proper material. These people just use the iron or steel. So these kind of stuffs happen when you don't have knowledge of proper design. You will see that person is just rotating a fan over a structure, and this helicopter is not taking lift. So these peoples are having good mind, but due to lack of the design, they fails to make the helicopter lift off. And you will see these persons are very courageous about their idea, but they failed. This is why design, the field of design is very important. Understanding knowledge of design, without that it is possible to make some kind of car or something like that by putting an engine, because in that case the requirement to maneuver the vehicle or requirement to make the vehicle run on road, the requirements are very less. like you need some 23 or 24 amount of 24 Newton meter of torque, very less torque, and the engine you are using, it provides a little bit more torque than the requirements. Because of that, it is easy for people to make any vehicle that maneuver over the road. But when it comes to design something like helicopter or plane, then the weight of the complete structure and the lift that is produced by that system, and the lift and weight ratio, these things becomes very crucial in all these cases. So you will see these people can make any car kind of structure, but they failed in making helicopter. So here you can see this accident has been happened in like Maharashtra. That was person known as a Munna helicopter. Yeah. So this person had made the same problem. The propeller was, his selection was very bad. I had personally gone through the design of the helicopter that guy had made. In this, the selection was very bad, because in these wings, the top one blades, what he did, he just used the wood covered by the tin sheet, and in the back side he used just iron. So at very high, he didn't calculate how much centrifugal force will be generated at this point, and he also didn't consider the ergonomics and the safety. So you can see at the driver's side everything is just open, and he didn't use any seat belt or helmet. If he used it would be, he may be alive, but he is right now dead, because he didn't realize the need of design. You will see at very high RPM, when RPM is limited, things are not that much dangerous. But when RPM or speed or all these goes beyond a limit, they becomes very dangerous. See, that wing has been just broken at that RPM, and that person had died because that wing had just collided with his head. So you can see that person is no more. So why design is needed? So design is needed to fulfill the three requirements. First is ergonomics, second is efficiency, and the third is effectiveness. So ergonomic means the safety for the people that is inside a vehicle or whatever the system passes through some kind of users, you can say that. And effectiveness means that at the boundary condition, whichever will apply on it, whether it may be a kind of windmill or a vehicle or anything we have. So whenever that thing will go through the different kind of life of its life span, in that period, a different kind of boundary conditions will be applied, like they may be bumps or something like that. So in that situation, in any condition, the stresses that are generated by the external boundary conditions must not be more than the strength of that specific material. So if the stress generated in that specific component is more than the strength of that material, it will start to either it will fail by in the way of fatigue, or it will directly rupture. So whenever the load is applying continuously over a period of time, then it will fail due to fatigue. And if it is you can see take an example of your earphone. So there is two ways earphone is broken. One way is that when you just take it and just tear it, and it will broken because the stresses you had generated at the end point of the earphone or something like that are more than the strength that material is having. And another thing is fatigue, means with time, due to repetitive loading, that component due to repeating loading, the component had failed. So by for that we do fatigue testing also. So fatigue testing is different, and the other ultimate the other kind of testings are totally different. So whenever you go you are going to design something for long period of time, you have to, or you have to consider the fatigue. But if you are designing something for very less number of means uses, you don't have to worry too much about the fatigue. You can take example of the like the rockets used. You don't think too much about the fatigue because you have to use the rocket for the one time. Like if you are going to design an formula vehicle, you don't have to think too much about the fatigue. Why? Because formula vehicles are not used for very long time span. They are used for just a few laps or races. That's why you don't think too much about the fatigue. But if you are designing like if you are designing a railway or some kind of vehicle that is used in general purpose, you have to take care of fatigue. You have to take care of fatigue because it will not, the component or the system will not fail instantaneously, but it will fail after some time, like 2 year, 3 year, or some kind number of, you can take example of a rubber band. You with time the rubber band start to fail. The cracks start to generated in the rubber bands, and after some time it just broken with just a small amount of force. That's it. So now let me show you. There is a so after understanding of the design, then two things come. So one is natural design, another is artificial design. Okay, so artificial you can see I have an example of artificial yes, yeah, nature is the best designer according to me available around the globe, because the way nature designs structure, nobody can do it. You can your body is an example of the best optimization could exist in the universe. You can see in if you are going to design something, how you will design, you will make pipe or structure, something like that. But what nature has did to your body is totally mind-blowing. So let's check here with the bone. If any other engineer is going to design a skeleton, what he will do is he will just make this take the solid components and he will design. But what nature did, nature didn't created anything very like filled or solid kind of structure. It made the nature created our bones in porous structure. You can see spongy structure. So by doing this, nature has saved the overall weight of our body. So if हिंदी में कह सकते हैं कि अगर नेचर वो करती, नेचर ने क्या किया कि टोटली हमारी जो बोन्स हैं, बोन्स को टोटली अंदर से बिल्कुल फिल ना करके उसने उसको स्पॉन्जी स्ट्रक्चर दे दिया. स्पॉन्जी स्ट्रक्चर देने की वजह से क्या हुआ कि आपको जो ओवरऑल मास है वो टोटली कम हो गया. अगर ये ऐसा नहीं होता तो आपकी बॉडी का वेट ही 100 kg हो जाता. जैसे हमने व्हीकल का फ्रेम बनाया, वो आपका 100 kg हो गया. आपके बॉडी का जो ओवरऑल फ्रेम है, जो स्केलेटन, अगर उसका वेट ही 100 kg हो गया तो आप मूव नहीं कर पाएंगे. तो नेचर ने क्या किया, उसको स्पॉन्जी बना दिया. जो सेकंड वर्क जो नेचर ने किया, नेचर ने किया कि आपकी जो बोन है उसको सेंटर से होलो कर दिया. राहुल राजपूत जी ने अभी बताया था कि जो बीम का एग्जांपल दिया था, जिसमें उन्होंने जो है उसका जो आईओडी है बीम का, उसको थोड़ा सा बढ़ा दिया था. और एग्जाम्पल तो ये नेचर से ही आया. नेचर ने क्या किया, हमारे बोन को सेंटर से होलो कर दिया. और जो आउटर पार्ट है वहां पर उसने चीजों जो ओवरऑल मास है उसको रख दिया. सो इन सेंटर में क्या हुआ कि आपको, जिससे आपकी बॉडी की जो ओवरऑल जो बेंडिंग स्ट्रेंथ है वो इंक्रीज हो गई. देन जो सेकंड काम नेचर ने किया कि डिजाइन, इन डिजाइन देयर इज अ वन थिंग कॉल्ड ऑप्टिमाइजेशन. फॉर ऑप्टिमाइजेशन यू हैव टू ऑप्टिमाइज फॉर द स्पेस और ऑप्टिमाइजेशन फॉर द मास. देयर इज टू काइंड ऑफ बेसिकली वी ऑप्टिमाइज थिंग्स फॉर टू थिंग्स. First optimization for the, we can say, space, and optimization for the mass. So by this method nature had optimized our bone for the mass. Okay, so now nature wants to optimize our bone for the space. So for the space, what nature had did is nature filled that inner space with bone marrow. Otherwise bone marrow, if nature didn't place bone marrow here. Nature have to fill some other gap. Nature have to move this bone marrow to some other place. So by like in this manner, nature saved the space and mass both. Like the in the same manner, you can see the honeycomb structure. Honeycomb structure is the most optimized shape ever available on this earth. You will if you modify something for the space and mass, the structure of the honeycomb, the honeybee make, is the most optimized structure. So we can say that at every instant, nature is going through iterations at billions or trillions of places. Continuously, nature is just doing changes, designing it. It takes it makes changes in 1 billion species, then accept the positive changes and discard the negative changes. In this way, what nature does is nature applies a billion trillions type of number of iterations and choose the best one. You can see the structure of your finger. You can see a number of things are there. Nature just optimized. So that's why biomimicry is the best path to understand the design. You go through nature and you understand what kind of things all these are. So now, after designing something, the things starts for optimization. For optimization, there is 4 type of optimizations are there. Okay, so topography, topology, size, and shape. Size optimization means whenever you have to decide the size of something, like you have to decide the size of the wheelbase, the size of anything like that. So what you do is you prepare the component of different sizes, you run analysis on it, you apply the boundary conditions, go through the result, choose the most optimum things. In this way, the size optimization happens. And in the shape optimization, you try different shapes. Just a minute. So in topology, there is 2 other different methods of optimization, that is topography and topology optimization. This is called topology optimization. In topology optimization, what we do is we observe that structure, we go for the places where most of the stresses are generated, we reduce the mass from the place where there is a very less amount of stress, we remove material from there and apply material to the place where the large amount of stresses are generated. So like this we do topology optimization. And there is topography optimization is also there. In topography optimization, what you do is you change the topography of the component. You can see wait, let me show you. Yeah, here you can see there is topography optimization in this. So you are having this kind of component, you didn't reduce the mass because the material you used is the same, but you just changed the graphical structure of that component. And by changing the graphical arrangement of the material in this component, you got better stresses and displacement reports. So like this we do topography optimization. So this is about design. So now let's go for the software part. So there is a number of softwares that are available for design. In design, there is 3 things. So first of all is CAD design. Second one is CAE, computer aided engineering. And the third one is CAM, computer aided manufacturing. So in CAD, what you do is you make the component. You make its geometry and everything. In CAE part, you do analysis and optimization, and CAM you go for the manufacturing part. So let's move for the CAD part. Okay. So for CAD, you can use SolidWorks, CATIA, ProE. All these are CAD softwares. You can do CAE in these softwares too, but there is some specific softwares are there for the CAE engineering. Those are like Altair HyperWorks and ANSYS, Nestran, Petran, and other softwares are there. COMSOL is also there. So we will use SolidWorks. Okay, so this is SolidWorks. You can apply for the student version of this software. For creating any design in SolidWorks, first of all, you have to understand the concept of the planes. So plane are something on which you make 2D 2D sketches and make reference to other entities too. Like there is 3 planes, front, top, and right. To make anything, there must be references. So front, top, and right, these 3 are planes on which we have to draw, or we can create our custom planes if needed. So here you can see, I take okay. So this is the front plane. We will make design sketch on the front. Okay. Let me create another part. So we took the front plane. Okay. So now we have to create the front structure of the we can say the frame. Okay, so here which these are the control panels of SolidWorks. Here you can control the other this is the toolbar. From there you can control the tools. And so first of all, to create the frontal part of the frame, we have to make 2D lines. Here this one is, we had created a rectangle, so now we have to make it constraint. We didn't given any kind of dimension to it, so you can see we can move it freely. So this is not the constraint one. So to make it constraint, we have to just click on smart dimension, select the specific line of graphical entity. We have to make its dimension. So here we will put to 100. So you can see this these 2 lines are constrained. You can move it like this, but you can't move it like this. So we again have to make it constrained like this. So we'll make it 100. So now we will create a plane in reference of the front plane. So now we'll create another plane in reference of the front plane. To create another plane, we will click on, you can here reference geometry. First of all, we come out from the sketch, and now we will click on the plane, and in reference. Okay. मीटिंग क्लोज कर देंगे, लेकिन ये मेरे पास वो आई नहीं रही ना कहीं पे सीधे कुछ। हेलो, so now we will create name of the software. So I will give you at the end. Okay, so first of all, you can see in the reference of front plane, I had created another plane. You can see here. Okay, so I can define that different plane. The other plane I can define in relative to that front plane. I can choose any other plane too. So you can see a different kind of so you can make another reference from other entities too. Okay, so now I had created another plane at the distance of 100 mm from this one. So here you can see another plane is created. So now I am having one more plane. These three are the global planes. It means that if you are going to use any kind of software, it is not limited to only SolidWorks, but if you are going to use any kind of software in future, like you are going to use CATIA or Pro, something like that, in those softwares, there will be also three planes that are global planes. In reference of these planes, our component is defined. So whenever you will export this component from this environment to any other environment, the geometries will be referenced from the origin, and that origin contains these three planes, and every operation we will do in SolidWorks or any other CAD software will be referenced related to these three planes, and the center point that is defining these planes, this is origin. Okay, everything will be in relative to this origin. So now we can choose another plane that we had created right now. You can see, and now we can make sketches on this one. Okay, so yeah, so let me give you another example. Like this, I created a rectangle. Okay, so that rectangle is not constrained. Okay, we can move it anywhere, we can just change anything. So like first of all, what we will do is we will make its centers, so we will make them coincident. So now you can change the length of the lines, but you can't move its center point. So to make these constraints, we will select the smart dimension. You can choose you can make, you can constrain the two lines by selecting these two lines. You can define the center point distance between them like this. Okay. So the distance between these two lines is 180, or you can just give the length of any specific line like 120 mm. Okay, now you can see, now it becomes black. So black means this one is completely constrained, so there is no movement. You can see here. So now we'll go out of that sketch. So now we are having these lines. So now we have two options: either create plane intersecting these 2 points, or we can go in 3D design panel. In 3D design panel, whenever we will draw a line, that line will consider the specific points in reference. So there is a difference between making 2D geometries and 3D geometries. Whenever you draw any 2D geometry, it is on some kind of plane. Either that plane might be created by you, or it might be on some structure, like you just extruded something and on the plane surface there is a face. It will consider that face as a plane too. So like this, if you make these lines in this manner. So the first one, this is the initial point. So you can see this is the frontal structure of the frame. So this is line data. We didn't created any, kind of like sectional view or something like that, but we created the line data. From this 1D line data, we will apply the weldments. In weldments, what it will do is it will create the weld points and give the sections to the 1D data of this frame. Okay, so now here there is a weldments. We will go out of this. So here these are weldments. So whenever we choose weldments, there is a standard. There is a inch or ISO mm. So there is different kind of profiles are available. You can custom your profile too. So here, like we have chosen the pipe. Different shapes are there for the pipe. So we choose 21.3 into 2.3, and now we have to choose the lines. And according to these lines, it will create the profiling around these lines. So in the same manner, you can create this. So like this, you will create, first of all, you will create the point, first of all, you define the points, and according to that points, you create the lines, and from that lines, you apply the profiling. This type of designing is used when you are preparing any chassis frame, not for the chassis. In case of chassis,